In our last video, we looked at how we could use synthetic division to determine whether a given number was a zero of a polynomial. What we're going to look at in this video is determining whether a number is a zero. If it is a zero, then factoring out the factor that goes with that zero, and then finding all of the other factors and zeros of that polynomial. In other words, completely factoring the polynomial. So let's say if I asked you, is -3 a zero of f of x equals x cubed minus 19x minus 30. In our last video, we learned how to do that. So I want you to see if you can do that yourself. Determine whether -3 is a zero of f of x. And we're going to do this using synthetic division. We're not just going to plug in -3. Because even if that does tell me that it's a zero, if I get equals 0, it doesn't help me with what I'm going to do next, which is to find the rest of the zeros and completely factor this polynomial. So use synthetic division to determine whether -3 is a zero of this function. Pause the video, do that work, and then start the video back. So we see if we're given just the number here, to see if it's a zero, we use the number exactly the way that it's written. So we put the -3 out here, and then we list our coefficients along the top, but we always want to be careful. Do we have all of them represented? We have cubed, and then we jump straight to x to the first power. We do not have the squared term. So we're going to take the 1 for the x cubed, we have to put in a 0 for the x squared, minus 19 and minus 30. And then we can do our synthetic division, drop the 1 straight down, multiply, and add all the way across. And -30 plus 30 is 0. And I always put this line right here because that helps me differentiate between my quotient and my remainder. So if the question is -3 a zero of f of x? We see that we have a 0 as our answer right here. Our remainder is 0. So the answer to this question is yes. -3 is a 0. Let's say I asked another question. And I said, given that -3 is a 0 of this polynomial, find all of the zeros and completely factor f of x. Now we know because we have x cubed right here, our polynomial is x cubed, that we're going to have 3 factors. That's the only way I can get x cubed is an x times an x times an x. So we're going to have 3 factors, and we're going to end up with 3 zeros, 1 from each factor, unless several of our factors are actually the same factor, in which case you would only list the 0 that goes with them 1 time. So if we look at what we have right here, if we look at our result here, what we just did when we did this synthetic division is we had divided out the factor that goes with x equals -3. And the factor that goes with the 0, -3, is x plus 3. Because if I set x plus 3 equal to 0 and solve for x, I get x equals -3. So the x plus 3 goes with the -3. And then what we got when we did the division was our quotient right here, which is x squared minus x minus 10. So what we just did, this synthetic division right here, we used it to answer some questions. Is -3 a 0? And we saw yes, it was. But if I want to completely factor, what I have to do is take the quotient here and solve that equation. And we see that that is a quadratic equation, x squared minus x minus 10. So from here we can use quadratic methods, and we can see what the two factors of x squared minus x minus 10 are. So go ahead and factor that. All right, well, evidently I've made a mistake somewhere because I actually intended this one to factor, but there are not two numbers that multiply to give me -10 and add to give me -1. But that's okay. I can still solve this problem. But as soon as I see right here that x squared minus x minus 10, if I'm solving this for x, finding my other two zeros, because I have a 0 of -3 here, and I know that I need two more zeros from that. And if it does not factor, I do have a b term, then I'm going to have to use the quadratic formula. So I want you to pause the video, try to write the quadratic formula from memory, identify what A is, what B is, and what C is, and solve this quadratic equation. Pause the video, do that work, find your other two zeros. All right. So we see that our quadratic formula is -b plus or minus square root of b squared minus 4 times a times c all over 2a. A is 1, b is -1, c is -10. Ah, I see where I made my error. We do not have to use the quadratic formula. I just figured out my error. Notice right here, I have -3. And when I wrote my quotient, I put -1. That's where I made my error. So hopefully you figured that out before you did the quadratic formula. But if you did do the quadratic formula, that was good practice. And I do apologize for that error. So let's go back and kind of reiterate what's happening here. -3 was a 0. We did the polynomial division with -3. We got x squared minus 3x minus 10 as my polynomial. Minus 3x here. So we have 1 0. To find my other two zeros, I can factor. I already have x plus 3. I can factor x squared minus 3x minus 10. I'd like you to go ahead and do that factorization and find the other two zeros. So we're looking for two numbers that multiply to give me -10. I know I have to have an x and an x. Two numbers that multiply to give me -10 add to give me -3, and those are going to be -5 and +2. So all three of my zeros are going to be -3, positive 5, and negative 2. So I have found my factors. And I have found my zeros. And I did end up with 3 of each, as I knew that I would. All right, let's do another one. Let's do another problem here. Let's say that I have f of x is equal to x cubed minus 11x squared plus x minus 11. And I tell you that 11 is a 0 of f of x. Find the other two zeros. And I know that there's going to be two more, because I have x cubed, I have 1, so I need 2 more. And then we're also going to completely factor. And we're going to see that we're going to have to do our finding our zeros and our factoring in opposite order as we did the previous one. So I want you to go ahead and do the synthetic division with 11. And then I want you to write the polynomial f of x as a factor that's been factored out with the 11, and then what your quotient is going to be. And we know that our remainder should be 0 because we're told that this is a 0. If your remainder is not 0, you've made some kind of mathematical error, so double check that. Pause the video, do the synthetic division, rewrite the function as 2 factors. All right, so we do 11. When we're given the number, we just use the number exactly the way it is. We have all of our numbers here, x cubed, x squared, x, and constant, all of our terms. So we have 1, negative 11, 1, negative 11. We drop the 1 down and we multiply and add all the way across. And we have 0 as our remainder, so we see yes, that is a 0. And what we just did, our synthetic division that we just did, is we divided out x minus 11, and we were left with x squared, 1x squared, plus 0x plus 1. This is not completely factored because this is still x squared. To be completely factored, we need x, x, x. X squared plus 1 will not factor. But I can find my other two zeros by taking just this piece and setting it equal to 0 and solving for x. And we know how to do that. That's something we learned how to do when we learned how to solve quadratic equations. And remember our process. Our very first step is to look and see, do we have a bx term? If we do not, we're going to isolate x squared and take the plus or minus square root of both sides. Go ahead and do that for me now. So we see that we subtract negative 1 from both sides, and then we take the plus or minus square root, so we get x on the left, plus or minus square root of negative 1. Now we know that we have a special name for the square root of negative 1. We call it I. We never leave a negative under the square root. So this is x equals plus or minus I, the imaginary number I. So my 3 zeros of this polynomial are the 11 that I was given, negative I, and positive I. And that is my 3 zeros. What if I wanted to backtrack and find the factors? Because that was the second thing I was asked to do here, to completely factor. Well, we know that if A is a 0, we know that x minus a is a factor. It has to have those x's in there so that when I multiply those together, I get the polynomial. That's what it means to be a factor. So my polynomial is going to be x minus 11, using this factor, or excuse me, this 0, times x minus negative I, which is x plus I, times x minus I. So those are my three factors. If I were to multiply these together, get that polynomial, and then multiply by x minus 11, I would have the original polynomial. In our next video, we're going to look at what do I do? How can I completely factor a polynomial and find all of the zeros if I am not given a polynomial or a zero to start with? How can I find